Hey class, welcome to the slide notes for lesson 7.3. Some of you are coming back from spring break. Some of you are starting in-person class today. That's awesome. Can't wait to see everyone get better and keep learning more math. So our warm-up question today is you're going to look at what I did here when I multiplied these two polynomials, these two binomials. What did I do wrong? And then resolve it. Like maybe it might be helpful to resolve over here. But I have at least two errors, so you should be able to spot at least two things. Actually, I think if you counted all the errors, there might be 4 or 5. But try to figure out what did I do wrong when I was solving this problem. All right, today we are learning some patterns. Again, math is the study of patterns, so when we talk about multiplying binomials, there's some things called the square of the binomial pattern, the sum, and the difference patterns as well. So these are going to be important things for you to make notes of. Alright, so there's a lot of text on this page, so we're going to go through this slowly. I'll show you what to write down in just a second, but for now just read through and listen. So when we talk about using the square of a binomial, we're talking about when we multiply, binomials together. So if we have a plus b quantity squared, that's really a plus b and a plus b. When we multiply those things, you would always get an a squared, you'd always get a b squared, and you get two ab's. So because of that, you're actually able to work through this problem and you are able to always get plus 2ab. Now let's say you change that. Let's say instead of a plus b, we change it to a minus b inside of here. Well, you'd still get an a squared and you'd still get a b squared, but now you'd have a times b, or a times negative b, and you'd have two of those, so now you're left with a negative 2ab. So again, the main thing that you guys need to make sure you're writing down is these two rules. And these are patterns that you can just trust. So if you ever see the format of a quantity squared, instead of rewriting that quantity out twice and distributing and solving, there's nothing wrong with doing that, but instead of doing all that, you can trust there's a given pattern that will always exist. If it's a plus b, then it becomes a squared plus 2ab plus b squared. If it's a minus b, it becomes a squared minus 2ab plus b squared. For both these, you always get a and b squared, and you always have a 2ab. It's just if it's a positive in between, it stays positive. If it's a negative in between those two, it becomes negative. Let's go use this pattern and see how it can help us solve problems a little bit faster. Alright, so as you remember, our final answer is always going to become a squared plus or minus, based on the value in between, 2ab plus b squared. So that's just something to keep in mind as you're using these things. So again, our first one here, we see it's plus, so we're going to use the plus feature here. Our a value is the first term, so it's 3x. Our b value is the second term, so it's the 4. So in this one here, I would rewrite this as 3x squared plus 2 times 3x times 4 plus 4 squared. Noticing that for each one of these, I'm taking my a value as 3x because it's the first piece, my b value is 4, so I'm plugging it into these same spots. As I work this through, I would get 9x squared plus 24x plus 16. Again, makes it really simple because we can just multiply as we're working things through. This also works when we have double variables. So this we have 5x and we have a negative 2y. This one is a minus, so we have to make sure we use the minus 2ab this time. So here we'd have 5x quantity squared minus 2 times a, which is 5x, b, which is negative 2y, and then plus, we're going to have, again, negative 2y quantity squared. That's a y in there. Sorry, I got a little tight. As we work this through, this just becomes 25x squared plus, noticing here, Oh, just kidding, that is a minus. Again, when we identify b, our b for this one was just 2y, so notice I had to make this change. So I checked my notes up, my bad on that one. So again, our b is just the 2y. Because we use the minus here, we don't re-put it into both of these. So again, continuing on, now we have a minus 2 times 5 times 2 would be 20 xy, followed up by a plus 2y squared. This would just become plus 4y squared. Alright, we have another pattern that we can always trust. If we have a plus b and an a minus b, so both the terms here are the same values, but they're just adding and subtracting of each other, your final answer is then going to have a squared minus b squared. And you can see an example here with x plus 2 and x minus 2 becoming x squared plus minus 4, and another example right here of x plus 3 and x minus 3 becoming x squared minus 9. Oh, if you can hang it tight for just a second. Alright, so make sure that you write down this core idea, and it's called the sum and difference pattern. We're going to use on the next page. Alright, so again, our sum and difference pattern, remember our final answer is just going to become a squared minus b squared. So as we look at these types of things, our answers for this first one would just become t squared minus 25, because we're taking the a's, multiplying them, and the b's, and multiplying them. Same thing for this one. We have, notice, the same values, just one is positive, one is negative when we're multiplying. So for this one we get 3x squared minus y squared. I think when you solve that one through, we have 9x squared minus y squared. You can also use this to help you solve out different things. So when you think about the numbers in between them, you can break things apart. So then we can say, well, hey, 26 is really, 30 minus 4 is 26. And then 34 is 30 plus 4. Noticing that there's the same number between those two. Because we have that plus and minus, we can multiply these and we can just do the difference of squares. So we have our 30 squared minus 4 squared. Therefore this becomes 900 minus 16, and you can get 884 rather quickly. That's it for examples today. Again, it's a lot of computations. We're coming right back, so it's a good lesson to come back into to kind of get your feet wet again. If you have any questions on the homework, let me know. Thanks.